So how does this graph relate to oxygen binding in the alveoli versus the tissue? So here, this is from your textbook, and I really like these diagrams because it shows you these red balls are the oxygen. It shows you the 4 oxygens at 100% saturation, and then here's 50% saturation with 2 oxygens, 25% with 1 oxygen. So I just really think that's a good way to show it. Again, this axis here, the x-axis, is showing you the partial pressure of oxygen in various locations. At a partial pressure of 40, if we go up here, we get to this location on the hemoglobin saturation curve, and so hemoglobin is about 75% saturated. So it is dropping off one of its oxygens in the tissue. And then in the lungs, it's about 100%, close to 100% saturated. So it's picking up oxygen in the lungs. So that just makes a lot of sense. Hemoglobin saturation in the lungs can be changed by altitude, but only slightly. So this is an example, and that's because the curve is relatively flat up here when we're in the alveoli. And that's useful because you want, no matter what elevation you're at, if you're in the mountains versus at sea level, you want your lungs to pick up oxygen. So even though the saturation has gone down slightly from 98 to 95%, hemoglobin is still grabbing onto the oxygen, even when you are climbing in the mountains. Now, the hemoglobin saturation curve in the skeletal muscles is going to change drastically because we're in this part of the curve that changes rapidly. So it's no longer a flat part of the curve. It's a part of the curve that changes. And so you can see even just a slight change in partial pressure of oxygen from 40 to 20, which you might see in active tissues, like this guy down here swimming, you've changed from a hemoglobin saturation of 75 down to a molecule that's only 40% saturated. So you've gone to a situation where you have 3 oxygens bound to one where you only have 1 and sometimes 2. So that's a drastic change, and what that means is that these extra oxygens are getting dropped off so that they can go and act in that active tissue. So it just really makes a lot of sense.